Okay, so what we have here is the data from the lab. And if you didn't do the lab, that's all right. I have some sample data here. You can just click on that and it'll bring you, guess I should erase that. All right, so that'll bring you here. And then you're going to want to make a copy of this because I didn't give you editing privileges so that one person doesn't edit it and make everything different. So you're going to want to make a copy of this, call it with your name, and that'll give you this. All right. So the first thing, you may not have done these in numerical order, and you might want those in numerical order. So you're going to want to pick all this. And to do that, you want to go to data and you want to sort that range. And you want to sort that range by the volume. So you're going to say, hey, this has a header row, which means those are titles. Don't sort that. And I want to sort it by the volume. And now all the numbers have been put in numerical order from volume and then whatever corresponding number went with that. All right. So that gives you that. The second thing you're going to want to do with your data, which I've already done with mine, is you want to add 0.5 to every volume. And that is going to account for the volume we said was only in the syringe. There's actually some volume in here, some area here where the sensor is that we did not account for. And so in order to account for that, you want to add about 0.5 to every volume data. So you can just put 0.5 on everything. All right. Now, it turns out you know that y equals mx plus b, right? Equals mx plus b. That should not surprise you. What we want to do is see if we can get a linear relationship here. And you should already know, based on the graph you had, that this is not linear data. So if we put all this and we say data and we say, oops, no, I want to insert a chart. And the best chart is always a scatter plot. So for our stuff, we got a scatter. And that should have been, that's volume down here, and that's pressure over there. Okay, so that should look like that. And that's not the right title, I don't think, but whatever. We'll just keep moving. All right, so you remember that from when you ran this thing. Let's get rid of that, right? Where there's sort of this trend line going down like this, sort of flattening out. All right, so it turns out that is a thing that where one goes down and the other one goes up. Oops. How did that happen? Oh, because I'm on the wrong one. Okay. So it turns out that since one is going up and the other one's going down, that means there's a relationship. And I'm sorry I put that on the other one, but that's all right now. That there is very likely some inverse relationship here. And one way to figure that out is to see what happens when you multiply these things. So we are going to set up this cell here as volume times pressure. So that means it's going to be equal to whatever the volume is. And we just click that to get this B2. And then we're going to hit times, which is above the 8. And you're going to hit the pressure. And then you're going to hit enter. And then the computer is going to figure that out for you. So what this did is it multiplied 5.5 times 250 and gave me this number. Now I want 8.5 times 181 here, and I want 10.5 times 147 here. And rather than do that every time, it turns out since I want the same function to go for every one of these cells, you just drag down like that. And what you'll see here is sort of what we suspected, that these are equal to a constant, right? You're getting about the same number every time except for the first one. And that probably has to do with when you were increasing the pressure, maybe some leaking out or whatever. That's not unusual. So, but the fact that these numbers all look alike is a very good indication that this times this equals a constant. So going back to y equals mx plus b, if we're trying to get something into that sort of formula, what we know is that the volume times the pressure equals a constant, right? Equals some constant. And if we want to isolate one thing, let's isolate the pressure, which is our y. So if you remember, right, that's our y value. The pressure is our y value. So if we want to isolate that, we got to divide by V on each side. So pressure will therefore be equal to, that should be a capital P, pressure is equal to 1 over V times K, right? k times 1 over v. It's 1 over v. Now that is looking like a linear formula, right? Y is equal to the constant slope m is the constant, and then the x is 1 over v. So if we take all these volumes and put a 1 over them, we should get a straight line. So let's see if that works. So we go here to this cell, and we want this cell to be whatever the volume is with 1 over it. So again, we're going to start with an equal sign, equals the 1 divided by, and we want it to divide by that volume. And we hit enter. And now that did the math for us. That took 1 and divided it by 5.5. Now in this box, we want 1 divided by 8.5. And in this box, we want 1 divided by 10.5. So we're going to just drag this down. We get this little cross because Jesus is the way to getting answers. And you're going to drag down on that little dot all the way down again. And now that did all the math for us. So if we want to prove to ourselves that this is a straight line, we now just need to graph this. So we're going to insert a chart, and that'll bring this up. And we want a scatter plot again, which is nice to see. For the x-axis, we want the 1 over v. So we're going to click here, and it's going to say, what do you want on the x-axis? And we're going to say, we want all this in the x-axis, and we're going to do that. And it didn't work. We're going to do that. And we do that. And we say, okay. And it still doesn't work. All right, let's try. I don't know why this doesn't work whenever I've done this a few times now, not live. All right, so let's just grab some stuff. Let's grab these two and say insert chart. Insert chart. This will work. Oh, look, that worked. All right, but it's not what we want. So we got to go to the scatter, and we need to edit the x-axis. We want the x-axis to be the cancel. We want the x-axis to be edit to be these values here. So we'll say okay there. And that maybe worked. And we want the y-axis to be the pressures. So we want that to be those there. All right, now let's take a look at this thing. And you can see that's a line. And if you don't believe it's a line, you can go to customize and the series, and you can say put in a trend line, and look, there's a straight line. Isn't that wonderful? That's math, kids. All right, so that is what we learned. What we learned is that the volume and pressure times each other equal a constant, and here's our constant for the most part. It's about 1,545. And if we wanted a straight line, because as scientists we always love straight lines, we can manipulate the equation to be like a y equals mx situation, where we have pressure as our y and 1 over v by dividing out the v on both sides. So we get pressure equals m times x. And so our x-axis is 1 over v, and our slope should be about what that constant is, and our pressure is our y-axis. And there you have it. That is not the right title, but that is what you should have learned by doing this.